Okay, this video is a practice for those of you that are taking the ACT and also a review of exponents and radicals for those that still need to take your test. So it combines both things in one. This first one feels a little overwhelming because we haven't done one like this, but let's just kind of break it down and see what we can figure out. We know that we've got fractional exponents and we know we've got radicals. So we need to somehow change the fractional exponents to radicals, which we can, but because there's this different numbers in the denominator, we'd have to have two different radicals, and that's not what they want the answer. They want it to have one radical. So to do that, we need to get common denominators for these fractions so we can put them under one radical. So right now we have 1/3 and 5/4. So the common denominator would be 12. So I'm going to multiply this one times 4, so that gives me 4/12, and this one by 3, so that gives me 15/12. So essentially now what I have is x to the 4/12 and y to the 15/12. But because they have the same denominator, now I can put them in one radical. So we know that the x and y go under the radical. The number in the denominator, because it's the same, we can just have the one radical, goes on the shelf. And then the numerator is going to be your different exponents. So I can have x to the 4th and y to the 15th. The problem is this answer that we wrote is not one of our choices, but we know if there's a 12 on the shelf, that means they're looking for groups of 12. Well, there's no groups of 12 in 4, but there is a group of 12 in 15. So we have one group of 12, so that comes outside. We still have the 12th on the shelf. The x to the 4 didn't change. And there was 15 y's, and we took out a group of 12, so this one y represents 12 of them. 15 minus 12 is 3, and this answer is there. Okay, number 2, they've got a lot of words in here, but this is where the problem is. And when there's two parentheses next to each other, that means multiplication. So if we multiply, we add the exponents. So the first one, we have a 5 and a 4, so we have x to the 9th. So that eliminates these answers. With the y's, we have 3 plus 3, which is 6. So now we know it has to be this one, but you can check it with the z's. 2 plus 6 is 8. Now they tried to trick you on g because with y, instead of having the 6, which is 3 plus 3, they had 9, which is 3 times 3. So just be careful. Okay. 54 is another one that looks like it's a real big mess, but let's see if we can just break it down and see if we can get an answer. Our problem right here has everything in radicals, and our answer has everything in fractional exponents. And normally we've gone from fractional exponents to radicals, but there's no reason why we can't go from radicals to fractional exponents. We can flip back and forth. So let's change this one. This one would be x is our base. Whatever is on the shelf is the denominator of our fraction, and the exponent is 4. This one, x would be the base. Number on the shelf is the denominator, and the exponent is the numerator. Now that we've rewritten it, doesn't look quite as complicated. Now we can see they're definitely asking us to multiply. Okay, so if we're going to multiply, that means we have to add the exponents. So I have 4/6 plus 4/3. So my common denominator is going to be 6, which means I multiplied it by 2. So I multiply this by 2. When you're adding, we add the numerators, keep the denominator the same, and 12/6 is really 2. So this is x squared, which is that answer. Okay. 6 is a pretty easy one. They want to know x to the 4th raised to the 6th. Well, power to power, we multiply the exponents, and 4 times 6 is just 24. So we have x to the 24th. Number 4, we need to simplify this. So we know we got the negative out front. 28 divided by 4 is 7. So now these answers are gone. We have 4 x's on top and 1 on the bottom. We cancel and we get x to the 3rd. So this is the only possible answer, but we can check it. We have 3 y's on top and 1 on the bottom, so we cancel and we get 2 y's. So yes, it doesn't work. Okay, 35 looks like it would be a real doozy of a problem, but we know how to deal with this. On this one, it's got a negative exponent. And we know that we can't work with negative exponents, and to make them positive, we move them. So if it was negative on the top, we move it to the bottom, and if it's negative on the bottom, we move it to the top. This one happens to be in the numerator, so we can just write it 1/3, and stop writing. Oh, hold on. Oh, trying to make it work here, folks. Okay, you should be able to see it now. Okay, so because it's a negative exponent, we're going to write it 1 over, oops, got a little carried away on my 3. We have 1 over 3 plus x to the positive 100, which happens to be an answer. So we're good. Okay, we go to the next page. This one, another one that looks complicated, but let's just break it down. Let's just focus on the part that's under the radical. See if we can simplify that. But remember also too, I should have probably read the question, is for all the x is greater than 0, which of the following expressions is not equivalent? So which one is not the same? So we got to find a bunch of these are going to be the same. We got to figure out which one is not the same. Okay, so let's see if we can rewrite this. If I can rewrite this as a fraction, so this is x, then what's on the shelf is the denominator, the numerator, the exponent is the numerator. But then the whole thing of this is taking the square root. So we don't want to take the square root of it, but we talked about quite a bit that anything to the 1/2 power is the same as taking the square root. And that's definitely part of the test. So anything to the 1/2 power is taking the square root. So now we have power to a power, and we have power to a power, we multiply the exponents, and then we figure out what we get. So before we multiply straight across the top and straight across the bottom, but the 2's cancel, so we just get x to the 1/3. So anything that's not to x to the 1/3 would be false. So here's x to the 1/3, that's true, okay? Anything to the cube root is x to the 1/3, so that one's the same. Over here, if I change this one, I have x to the 6 denominator, 2 numerator. Well, 2 over 6 is 1/3, so that's 1/3. Now this one you may not realize but how to simplify it, but this one, that's definitely not 1/3. So that one has to be the one that's not true. Okay, let's look at number 27. We got a to the negative second. Well, how do we make it positive? We move it. We write 1 over a squared. That's it. Okay, rewrite this one as a radical. So x goes under the radical. 3 is on the shelf. 2 is the exponent. Well, it always is. Okay, number 22 looks like it's just a hot mess, but it's really much easier than you make it out to be. So the goal is to figure out what a to the u plus v is. So we know it's going to be a to the something. So we somehow need to know what u plus v is. So let's look at each one of these things. So in the first one, it says a to the second power raised to the u is 12. Well, this is power to a power, and we know power to a power means you multiply the exponents. So to get that answer, they took 2 times u and got 12. Well, we can easily see then u has to be 6. Okay, let's see what they did over here. Over here, they said a to the v squared. Well, this is power to a power again. So v times 2 gave us a to the 8th, which is 8. So that means v has to be 4. Well, now that we know that, now we can find a to the u plus v. Because we know that u is 6 and v is 4. So this is just a to the 10th. Okay, number 4, we got another easy multiplication one. 3 times 5 is 15. So right away, these can't work. When you multiply, you add the exponents. So 9 plus 9 would be 18. So here's your correct answer. Those are no good. Okay, let's look at number 4. We just did one like this a little bit ago. The negative stays out front. 18 divided by 3 is 6. So those answers don't work. 3 x's on top, 1 on the bottom, we get x squared. 2 on the top, 1 on the bottom, we get y. This is the best answer. Those don't work. Okay, what about 56? It looks like a mess because we got a fraction over a fraction, but let's see if we can simplify it. On the top, I got 24 divided by 6. Well, when it's exponents, we subtract. So 24 minus 6 is 18. So I have x to the 18 over. On the bottom, somehow I just got to simplify this. And I can't leave it as 1 over x squared. But we did a lot of problems where it was something, and then we rewrote it as 1 over x squared. And we did that when we had negative exponents. So I can rewrite that as x to the negative second. Well, this is a division problem. And now that it's a division problem, that means we subtract the exponents. So I have 18 minus negative 2. So that's plus a positive. So I get x to the 20th. Now, if that didn't make sense in your head, remember if I have x to the 18th over x to the negative second, I can take this and move that up. So that's x to the 18th times x squared, which means you would add the exponents. So I still get x to the 20th. Okay, last couple. On number 28, we need to find the fourth root of that. Well, the fourth root of 256 is 4. If you didn't know that, you can put it into your calculator. So right away, those answers are gone. And then the fourth root means they want groups of 4. So how many groups of 4 are in 16? Well, there's 4 of them. So there's your answer. Okay, number 14, they would want you to do without a calculator, but the square root of 50 is a decimal. So we're not going to be able to figure that out. But there's a square root that's really close to 50 that we do know. We do know the square root of 49. So if I rewrite this problem, the square root of 49 is 7. So that's 7 over 2, which is 3.5. Well, 3.5 is exactly in between 3 and 4. So now we need to figure out a little bit more. Well, 50 is just a little bit more than 49. So that means the answer is going to have to be a little bit more than 7. So this one's got to be a little bit more than 3.5. So it's really going to be closer to 4. Okay, last one. We want to simplify that by writing it in reduced radical form. So if I have 3 over 4 minus the square root of 5, simplify that, we're going to multiply top and bottom by the conjugate of the bottom. And the conjugate of the bottom is going to be 4 plus the square root of 5. On top, 3 times 4 is 12. 3 times 5 is 3 square root 5. So now we know these doesn't make sense. Oops, I didn't mean to cross that one out. This doesn't make sense. And really, because it's a minus, that one doesn't make sense either. But let's keep going to make sure that E is really the right answer. On the bottom, 4 times 4 would be 16. A minus times a plus is a negative. Square root 5 times square root 5 is square root of 25, which is just 5. So when I simplify the bottom, we get 11. So it is, in fact, this answer.